Right, we're going to link in two parts here of the physics topic. We're looking at generating electricity, and also links in with radiation, because we are looking at nuclear power stations. Now, if you remember back to P2, we talked about how we generate electricity. We take a fossil fuel such as coal or oil or gas, and we heat it up, and that heats the water that makes the steam, that turns the turbine, that turns the generator, that generates the electricity that is sent out through the national grid to our homes. Well, we can do this in a nuclear power station as well, exactly the same way, except instead of having a fossil fuel, we use a radioactive substance, and we use a process where we can produce heat from a radioactive substance, and it's usually uranium, to give off loads of energy, and that energy is used to heat up the water, to make the steam, to turn the turbine, which turns the generator, which produces the electric. So the process is all exactly the same, apart from the initial fuel and how it releases the energy. Coal is burnt through the combustion process and releases the energy that way, and a radioactive substance works in a slightly different way. It works through this process called nuclear fission. Okay, now this is, like I say, we take uranium, which is used to produce heat energy in a nuclear reactor, and it's something called a chain reaction. So what happens is we take some uranium and we put it into the reactor. So splitting a single atom doesn't release very much energy, not really enough energy to power the smallest of electrical devices. Instead, a very large number of nuclear fissions are needed. When uranium atoms are split, they release 2 or 3 neutrons. If there are enough uranium atoms in a sample of material, a chain reaction may start. Neutrons released in the first fission go to make more fissions. So basically the neutrons are fired into the radioactive substance, and that will split the nucleus, and then that will release more neutrons. Those neutrons will then fire into the next lot of radioactive substance, and so it will carry on as a chain reaction. Okay, so if we have a look, there's a diagram here that will explain that. Okay, so as I said, you've got neutron that's fired into uranium. The uranium is split, and it forms barium and krypton, which are also radioactive, but it also releases more neutrons. Those neutrons are then fired into more uraniums, and then they're broken down again into krypton and barium, again releasing more neutrons. Now, in the sort of grand scale of it, it looks like really efficient. However, it can cause a big problem because it has to be controlled. So we need to have a way of controlling that. In a nuclear reactor, the fissions are carefully controlled so that on average one fission leads to one more fission, which leads to another one more fission, which maintains a steady and constant reaction. Special rods called control rods are raised and lowered into the reactor, and they are made of a special material that actually absorbs the neutrons, reducing the number available to go on and split more atoms. They are very carefully positioned to ensure that there are enough neutrons left to create further fissions, but not enough to cause the reaction to go out of control. Another thing to be aware of is that nuclear power stations are generally built by the sea, so the seawater can be used as a coolant to cool down the amount of energy that's being released. Okay.